So, hey everyone, we're going to talk about web components today. Full disclosure, I have ADHD, so I might bounce off screen as I move around a little bit today. But web components sit in this uncanny valley. They're not quite React components. They're not quite with the grain of the web either. But I think a lot of that is really just because we've been thinking about and using them wrong. So today, I want to show you what I think is a better way to use web components, or at least one that works with the grain of the web rather than against it. Mike, thanks for that great introduction. I'm Chris Ferdinandi. For those of you who don't know me, you can find me online over at gomakethings.com, where I teach people a simpler and more resilient way to make things for the web through courses, workshops, and my daily developer tips newsletter. I also consult with some amazing companies. And these days, that often means building custom web components, like I recently did for a project with NASA. The thing with web components is they've actually been around for a really long time. They were first announced in 2011, which is over a decade ago, and they've been supported in all major browsers for years. Now, when they first came out, a lot of folks thought they were going to be the thing that finally killed React. And if you're watching in 2024 or beyond, you know that they weren't. React has started to swallow up everything. People often use them like you would a React component. So a lot of tutorials that you see start with an empty custom HTML element, and then they use JavaScript to inject the HTML. Oh, and don't forget about the Shadow DOM. When web components first came out, there was a lot of hype around using the Shadow DOM to keep your HTML isolated from the rest of the UI. This was promoted as a key feature of web components. Of course, once you do that, your HTML doesn't have access to your global style sheets, so you need to inject your CSS with JavaScript too. This approach feels a lot like React, but native. But if you want React-like components or a React-like experience, React and smaller libraries like Preact, honestly, in my opinion, they do it better. And I know that sounds weird coming from someone who spends their whole career evangelizing vanilla JavaScript, but the reality is web components don't have data reactivity, although you can hack some of that in with proxies. They don't have DOM diffing. There is no browser native way to do that. And they don't have support for single file components, although if you use a plugin like Zax WebC, you can kind of sort of make that work. But if you're a developer who likes React, web components often aren't Reacty enough. But because this approach often starts with an empty element that relies on JavaScript to render its content, web standards and progressive enhancement evangelists like myself also dislike this approach. And I think this is why it feels like it's taken so long for web components to really catch on. So for the rest of this talk, I want to show you a better way. It's the approach that I used with NASA and various other clients to build web components that are simple, reliable, and that work more with the grain of the web. And so here's the agenda for the rest of this talk. We're going to start by talking about a new way to build web components, or a different way to build web components that's more with the grain of the web. We're going to dig into some tips and tricks that make working with web components easier, and we're going to round things out by looking at some specific examples, including building a web component this way from scratch. Let's start by talking about a new way of thinking about web components. That's honestly actually kind of old school. So in November of last year, Jeremy Keith wrote an article about this approach. And he wrote, "Try not to bring React mindset with you. Do you really need to invent an entirely new component from scratch? Or can you use HTML up until it reaches its limit and then enhance the markup?" And he called this approach HTML web components. It's a name that's started to stick, and I'm seeing it pop up more and more around the web. An HTML web component is all about progressive enhancement. So rather than an empty element, you start with perfectly functional HTML. Here we have a collection of headings and some content that goes with them. Let's imagine that we eventually want this to be an accordion component where clicking or tapping on the heading causes the content that goes with it to get expanded or hidden. We can use a web component for that as a convenient way to enhance what's already there into something more powerful and interactive. And we start that process by wrapping our content in a custom element. In this case, we'll call it accordion group because that's a very easy and obvious description of what this thing's going to be. When the web component runs and does its thing, the HTML in the DOM ends up looking a little bit different. You end up with button elements around the heading text so that you have a focusable interactive element. You get some ARIA attributes that indicate what's happening so that screen reader users understand the interaction patterns on the page, and the content gets hidden by default using the hidden attribute. But if this never actually ran, you would still have perfectly functional markup. And that's really the big difference between HTML web components and the way they were historically presented, and a lot of older tutorials talk about them. Now, this probably looks a lot like old school DOM manipulation. If you've been around for a while, this is how we used to build things. And honestly, that's because it really is. But web components bring a lot of big benefits that make building interactive UI a lot easier. For starters, they're, in my opinion, easier to write. You get to write your HTML as HTML rather than HTML and JS, yuck. And rather than having to create unique selectors that you pass into a constructor method, you define your web components once and wrap your HTML in your custom element. You can even have multiple versions on a page. Each one automatically instantiates as its own unique instance. Because functional HTML is already there, people get a usable experience immediately. And if your web component fails to load for some reason, users still have a perfectly functional experience instead of one that doesn't work. Web components also let you provide options and settings declaratively in the markup. This makes it a lot more obvious what's happening just by looking at the HTML. The behavior isn't hidden away in a JavaScript file somewhere, and you can include multiple instances, each with their own settings, through the HTML alone. No more instantiating multiple instances with different selectors and settings, often some JavaScript file that you have to hunt down every time you want to make an update. Let's look at some tips and tricks that make working with web components even easier. Now, if you've never created a web component before, I think it's worthwhile to start by kind of building one, and we're going to start with a custom element. Here, I'm going to use the most cliche of examples, a counter component. So you've got a button, you click it, and the text updates to indicate how many times it's been clicked or tapped or activated. This is honestly actually kind of a terrible example for an HTML web component because you're not progressively enhancing anything. The button is absolutely useless without the JavaScript. But it's a really simple tutorial to explain. So if you've never worked with web components before, it's a great way to kind of wrap your head around some of the concepts. So we're just going to roll with it. So we start by wrapping some existing HTML with a custom element, in this case, count up. And then in our JavaScript file, we use the custom elements define method to define a custom element and associate behavior with it. You pass in the name of the custom element as a string. And just as a quick aside, web component custom elements have to have a dash in them. Single word elements are reserved for browser native elements. So when you're making your own, it always has to have at least one dash. So we pass the name in, here it's count up, and then we pass in a class that extends the HTML element class. Your class needs to have a constructor method in it, and that runs automatically on each element and creates a unique instance of your component. And then inside the constructor, you always run the super method first. This gives you access to the properties and methods of the HTML element class that this class is extending. And then after that, you can run any of your custom code. Now, web components provide some useful ways to handle that. And in particular, they make encapsulation really easy. It's built in, even without the shadow DOM. So while light DOM elements, so things that are not in the shadow DOM, will still be accessible to your CSS and JavaScript and the main DOM, they're scoped to your custom element, and that provides some unique benefits. For example, in your web component, the this keyword refers to the current instantiation of your component, and by extension, the custom element that's wrapped around it. You can define properties on it. In this case, we're setting a count property of 0, and we're going to increase that every time the button is clicked. And you can search for elements inside your custom element by scoping them to the this keyword. So if I use the query selector method on this, I am looking for the button inside my custom element rather than everywhere in the DOM. So it makes finding elements in your component and manipulating them way easier. You don't have to use any weird special tricks. You also get built-in CSS scoping if you want it. By using the light DOM instead of the shadow DOM, your web component will automatically inherit your global style sheet styles. And this is, in my opinion, one of the biggest wins of this approach, because styling elements in the shadow DOM sucks. It's a terrible, painful experience. This gets around all of that. But if you want to scope styles in your web component, you can use the custom HTML element as part of your selector string. So here, our button is going to inherit all of the global button styles, and then we can override or modify some of them by prefixing our button selector with the count up element. You can even use CSS to detect when the JavaScript is ready with the defined pseudo class. And if you combine it with the not pseudo class, you can also detect when your JavaScript for that component is not ready. So if you've ever written a DOM manipulation library before and you've done something like add a class to the document or the body element, that way you can modify your styling depending on whether the library has loaded or not. You don't have to do that anymore. Web components provide a built-in way to detect that using the defined pseudo class. Web components also have some built-in methods that make handling events easier. With the add event listener method, you can pass in an object instead of a callback function as that second argument. If the object has a handle event method, that method will automatically run in response to the event and receive the event object as an argument. Now, why would you do that instead of using a callback function? A lot of it has to do with this keyword that we talked about earlier. In a normal callback function, this keyword doesn't refer to the instance. It refers to either the element or the window object, depending on the context in which it's used. But in the handle event method, this is the instance, which means that we can access those properties like count that we need to manipulate some things, as well as if we had other methods in our class, we could run those too without having to do things like use the bind method or some weird hacks with arrow functions and timing around when we create callback functions. And in this particular instance, we are increasing our count by 1, and then we're updating the text inside our button to show how many times it's been clicked. If you need to listen to more than one type of event, you can even create on methods in your class with each of your different event types, and then use the handle event method to automatically route them. So here I have an on click event, and whenever that event type fires, my handle event method is going to automatically run that method for me. So you don't have to use a bunch of like if else statements or anything. You can just set handle event to do all the work for you. With web components, you use custom attributes in your HTML to define your options and settings. For example, let's say you wanted to be able to define a custom starting number for your counter, in this case 42. You could add an optional start attribute to the countup element and then give it a value. In your constructor, you can use the getAttribute method to get that attribute and the parseFloat method to convert it from a string into a number. And then if that attribute exists and is a valid number, you use it for this count instead of the default of 0. But if not, you fall back. So users don't have to use it, but they have the option. What makes this approach particularly nice is you can now have multiple instances of your web component on a page. Each one can have their own options and their own settings and their own properties, and you never have to write any additional JavaScript. And you can tell just from looking at the element what its specific settings are and how you'd expect it to behave. And while web components don't have reactive data like React or Vue does, they do have a built-in mechanism for detecting attribute changes. For example, let's say you wanted to stop the countup component from counting when the pause attribute is added to it. First, you define an array of attributes that you want to observe and assign them to the static observed attributes property. And you do this for performance reasons. If you were watching every single attribute that could or could not be added or changed on an element, it could start to bog down the browser's memory and create performance issues. So you say, just pay attention to these. Whenever one of those attributes is changed in some way, the attribute changed callback method runs. And this will be triggered whenever an observed method is added, removed, or changes in value. And it receives 3 arguments automatically: the name of the attribute, its old value, and its new value. If you want to detect whether the attribute has been added, removed, or changed, you can check the old and new value properties. When an attribute was just added, the old value will be null because there was nothing there before. When it's been removed, the new value will be null. In all other situations where the value is just changing, it will be a string. It could be an empty string, could have some sort of value with it, but it will be a string. In this particular case, if the attribute was removed, so if the, if it was added rather, if the old value was null, we're going to remove our click event listener. So we stop detecting clicks. When the attribute gets removed, we are going to add our click event listener back on. Let's look at some examples of things HTML web components are particularly great at. Let's say you have a button and you want to show or hide some content when it's pressed. This is a classic show hide disclosure component. First, we'd start by wrapping a custom element around it. In this case, we will call it the obviously named show hide. Now you have an easy way to associate a button and some content that goes with it. But if there's no JavaScript, users still get the content. In our JavaScript, we'll start by defining our custom element. We'll pass in show hide and our class that extends the HTML element. And then inside the constructor for that class, we'll run the super method. And then we'll define our properties. Maybe we'll get the button using the query selector method on this. And then we will get the content, the next element sibling, and assign that to a property as well. That way we can access them later. Next, we'll set up the initial UI. We'll add an ARIA expanded attribute to the button with a value of false. This is an accessibility requirement, so it conveys to people who use screen readers what type of interaction they could expect from that button and what the current state of it and its content are. And then we'll hide the content using the hidden attribute. Now the HTML in the UI looks like this after our web component instantiates and runs. Next, we will add a click event listener to our button. And we'll do that by passing the instance, this, into the add event listener instead of a callback function. That way we can take advantage of that built-in handle event method. Under the ARIA authoring practices guide for a show hide pattern, the button should have an ARIA expanded value of true when the content is visible and false when it's hidden. So inside our handle event method, we can actually check the current value of that attribute on our button and show or hide the content accordingly. So if it has a value of true, content is currently visible, we'll change it to false, and we'll set the hidden attribute to hide that content. Otherwise, we'll set it to true to show the content and remove the hidden attribute so you can see it. Now that we have a functional component, we might try adding some styling to make it look a little bit nicer. We might, for example, change the button color based on whether the content is hidden or visible. We'll give it maybe a blue color as the default, and we'll make it darker when ARIA expanded equals true, which we can do easily by using an attribute selector in our CSS. And because we only want this to apply to our show hide component, we will scope our CSS to that element. And maybe we want to hide the button element until our web component JavaScript loads. Since it requires JavaScript to work, it's functionless until the web component starts. We can use the not and defined pseudo classes for that. And then we'll just slap a display none on our button to hide it. Another example we talked about a little bit earlier, web components are a great way to transform a collection of headings and content into an accordion group. No JavaScript, no worries. Users still have access to all of the headings and all of the content. I'm not going to walk through the code for the rest of these because we would be here all day. But just some more examples to kind of get your brain going on what you can do with this approach to web components. You might also take a list of anchor elements and their associated content and turn them into toggle tabs. No JavaScript, users get a perfectly functional collection of anchor links and content. One of my favorite uses, though, is forms. The project I did for NASA involved building out an entire app, and it was done almost exclusively through form interactions. I like to create forms that work with old school server submits and full page reloads by default. So you provide an action that points to some sort of server path. The form sends its data to that path, and the server does some stuff. Then I use web components to turn them into AJAXy forms that send data to the server asynchronously with the JavaScript fetch method and show a status message or update the UI instead of reloading the entire page. Without JavaScript, you still get a perfectly usable form, or in the case with the NASA project, a perfectly usable app. But with it, you get something even better, faster, snappier. If you forget everything else about this talk, and I hope you remember more than just this, but if you only remember one thing, I hope your key takeaway is to start with functional HTML and then enhance with web components. If you found this interesting, I put together a bunch of additional resources for you on building HTML web components. Over at gomakethings.com/11t, you can find articles, examples, boilerplates, and more. Thank you all so much. This was a lot of fun.